Webb revealed immense chaos, storms forming, clouds shifting, and Neptune's delicate rings reacting to the shock waves.
12 million light-years away, a galaxy is burning with the fire of creation.
And Hercules. Planets are not just sitting still in space, they constantly dance with each other, tugging and pulling through gravity.
In the silent, frozen reaches at the edge of our solar system, a breathtaking event unfolds, reminding us of the universe's endless wonders. A colossal traveler, racing through the darkness, meets a distant world in a moment of cosmic destiny. Waves of energy ripple across the stars. Around the globe, astronomers gaze upward in awe, united by curiosity and hope. Neptune, our enigmatic blue giant, becomes the stage for a cosmic story, its beauty now marked by the touch of the unknown. This is not a tale of destruction but of creation and discovery. The universe is alive, vibrant, ever-changing, and filled with possibility. Tonight we witness the aftermath, a luminous bruise on the ice giant, captured by the James Webb Space Telescope, inviting us to dream beyond our world. To truly appreciate the magnitude of this discovery, you have to understand Neptune itself. It's not just another ball of gas out there. It's the 8th and most distant planet from our Sun, a true outlier in our celestial neighborhood. Neptune orbits our star at an average distance of about 2.8 billion miles. That's 30 times farther from the Sun than Earth. The sunlight that reaches Neptune is 900 times fainter than the sunlight that bathes our own world. It is a place of perpetual twilight, cold, dark, and incredibly windy. Its journey around the Sun is so vast that one Neptunian year lasts for nearly 165 Earth years. Think about that. Since its official discovery in 1846, Neptune has only just completed its first full orbit in 2011. This immense distance makes Neptune incredibly difficult to study. From Earth, even with our most powerful ground-based telescopes, it appears as little more than a tiny bluish dot. Most of what we know comes from a single, fleeting encounter. In 1989, the Voyager 2 spacecraft flew past Neptune, giving us our first and only close-up look. It revealed a world that was surprisingly dynamic. Voyager 2 showed us a planet with a stunning azure blue atmosphere, punctuated by massive swirling storm systems, most famously the Great Dark Spot, a hurricane-like vortex the size of Earth. It also confirmed the existence of a faint, wispy ring system, a family of icy moons including the strange, cantaloupe-textured Triton. But Voyager's flyby was just a snapshot in time. It raised more questions than it answered. Neptune is, in every sense of the word, a mysterious and alien world, a perfect target for a telescope designed to see the unseen. Enter the hero of our story, the James Webb Space Telescope, or JWST. This isn't just another telescope, it's a technological marvel, an astronomical time machine, the most powerful space observatory ever built by humanity. Launched on Christmas Day in 2021, a joint mission, NASA, European Space Agency, Canadian Space Agency, its primary mission, succeed Hubble. But it doesn't see the universe the same way. Hubble observes visible light, Hubble observes ultraviolet light. Webb is designed to see infrared. This is the key to its power. Infrared is essentially heat radiation. Anything with heat emits infrared. First galaxies forming at the dawn of time, cold, distant planets in our solar system. Infrared lets Webb pierce cosmic dust clouds, see the birth of stars, see the birth of planets. It can analyze exoplanet atmospheres and look back to the first flickers of light. Webb must be incredibly cold, so it orbits 1 million miles from Earth, shielded by a 5-layer sunshield the size of a tennis court. Its mirror is a work of art. 21-foot wide collecting surface made of 18 hexagonal segments, each coated in a microscopically thin layer of pure gold. Gold reflects infrared exceptionally well. That mirror gathers the faintest light from the most distant objects with unprecedented resolution and sensitivity. A cosmic bucket catching the faintest raindrops of light. That sensitivity spotted subtle, profound changes in Neptune's frigid atmosphere. The impact would have been invisible to Hubble. Webb wasn't just taking a pretty picture, it was performing a planetary health checkup. So what exactly did Webb find that has everyone so excited? The discovery unfolded during a routine observation program designed to monitor Neptune's atmospheric dynamics. Scientists were comparing new data from September 2025 with the baseline images taken back in 2022. At first they thought it was an instrument glitch. In Neptune's northern hemisphere at a latitude of about 30 degrees was a region that was glowing with unexpected thermal intensity. This area, in the planet's upper stratosphere, should be one of the coldest places on Neptune, with temperatures dipping to around -360 degrees Fahrenheit. But Webb's instruments showed a localized area that was significantly hotter. Relatively speaking, of course. This thermal anomaly was the first clue. An impact from a comet would act like a cosmic meteorite. An impact from an asteroid would act like a cosmic meteorite streaking through the upper atmosphere and depositing an enormous amount of kinetic energy as heat. The object itself would vaporize, creating a superheated bubble of gas that would take time to cool down and dissipate. This is precisely what Webb detected, a lingering fever in Neptune's stratosphere. The size of this hotspot suggests the impactor was massive, likely several kilometers in diameter. The smoking gun came from Webb's spectrographs. They break light into its constituent wavelengths, like a prism. That lets scientists identify chemical elements and compounds. Webb analyzed the light from the hotspot and found a chemical cocktail out of place. There were surprisingly high concentrations of carbon monoxide hydrogen cyanide. These molecules aren't normally abundant in Neptune's hydrogen-dominated stratosphere. Their presence points to an external origin. These are the chemical fingerprints of a high-energy impact, vaporized projectile, and superheated atmospheric gases. Webb didn't just see a bruise, it performed a complete forensic analysis. An impact of this magnitude doesn't just leave a chemical scar and a temporary hotspot, it sends powerful shock waves both literally and figuratively through the planet's entire atmospheric system. The immediate effect is, well, kind of like throwing a giant boulder into a calm lake. Ripples, or in this case, atmospheric gravity waves, would have propagated outwards from the impact site, carrying energy through the different layers of the atmosphere. These waves can travel for thousands of miles, disturbing the delicate balance of temperature and pressure that governs Neptune's weather. We are likely to see the birth of new, powerful storm systems as a direct consequence of this event. Think about Neptune's already extreme weather. We know it has supersonic winds and continent-sized hurricanes. Now introduce a massive localized injection of energy. This is honestly a recipe for atmospheric mayhem. The heat from the impact creates a powerful updraft, a plume of hot gas rising from the stratosphere. This plume will disrupt the established east-to-west wind patterns, creating turbulence and vortices. Scientists predict that in the coming months and years we may see a new great dark spot emerge near the impact latitude. Furthermore, the debris from the impactor, a fine dust of silicates and vaporized organic compounds, doesn't just disappear. It gets spread throughout the stratosphere by Neptune's powerful jet streams. This dust can act as condensation nuclei, tiny seeds upon which Neptune's atmospheric methane can freeze. This could lead to the formation of new cloud features, new bright and unusually persistent cloud features. Webb will be watching closely to see if brilliant white clouds of methane ice begin to form and circulate around the planet, tracing the path of the impact debris. We might be about to witness Neptune's appearance change before our very eyes. This impact is now a massive, planet-wide experiment in atmospheric chemistry. The consequences of this cosmic collision aren't confined to Neptune's atmosphere. The impact event could have sent subtle but measurable ripples through the planet's gravitational field and its delicate system of rings and moons. While the impactor itself was not large enough to alter Neptune's orbit or tilt, the sudden redistribution of mass, even if it's just in the atmosphere, can create tiny transient wobbles in the planet's rotation. These are known as planetary seismic waves or Neptune quakes. A more observable effect might be seen in Neptune's faint and fragile ring system. Neptune's rings are not solid and uniform like Saturn's. Clumpy arcs, dusty arcs confined by the gravitational influence of small nearby shepherd moons. The impact would have blasted a plume of gas and fine debris high above the main cloud decks. Some of this material, ejected with enough velocity, could be thrown into orbit around the planet. Over time, this new stream of debris could interact with the existing rings, potentially brightening them, creating a new temporary ring, disturbing the delicate gravitational balance that keeps the ring arcs stable. Future Webb observations will focus on looking for subtle changes in the ring's structure and brightness. And then there are the moons. Neptune has 14 known moons: Triton, Naiad, Thalassa. The gravitational shockwave from the impact, while small, could have subtly perturbed the orbits of these inner moons. More directly, the expanding cloud of impact debris could pose a hazard. As this debris cloud spreads out, it could lead to a meteor shower on the surfaces of these small, airless moons. The most intriguing possibility involves Triton, Neptune's largest moon. Triton is a strange world, likely a captured object from the Kuiper Belt, orbiting Neptune in the opposite direction of the planet's rotation. While this single impact won't significantly hasten that process, it serves as a powerful reminder of the dynamic and violent environment that Triton inhabits. This discovery forces us to fundamentally reevaluate our view of the solar system. We have a tendency to think of the planets as being in their final, stable forms. We see them as they are now and assume they have been this way for billions of years. But the Neptune impact is a dramatic reminder the solar system is not a static museum piece. It is an active, evolving place where violent events still happen. Planetary formation didn't just end 4.5 billion years ago, it's ongoing. For decades, our only modern example was comet Shoemaker-Levy 9 hitting Jupiter in 1994. That showed dark, bruise-like scars in Jupiter's clouds, but that was a gas giant. Neptune gives us our first look at an ice giant impact. Different atmospheric composition, temperature, pressure. The effects will be unique. Huge implications for the early solar system. The late heavy bombardment about 4 billion years ago pummeled the inner planets. Earth, the moon with asteroids and comets. We still see those craters on the moon. We assume that bombardment was ancient history. The Neptune impact shows large impacts remain possible, a crucial data point for exoplanet studies. We found thousands of planets around other stars, many Neptune-sized. We analyze atmospheres for habitability. How do we tell a biosignature from an impact signature? We had no modern analog until now. Neptune gives us a template: study chemical signatures, thermal signatures of a known impact, and better interpret exoplanet data, learning about alien worlds by studying a dramatic event in our backyard. So, a distant ice planet got smacked by a space rock. Why should anyone on Earth care? It matters because this discovery touches on the most fundamental questions we ask as a species. Where did we come from? How did our world form? Are we alone in the universe? This event on Neptune is a piece of that grand puzzle. It's a real-world demonstration of the same physical processes that delivered water and organic molecules, the building blocks of life, to the early Earth. Comets, asteroids are not just sterile rocks. They are cosmic delivery vehicles carrying these vital ingredients across the solar system. This discovery underscores the importance of planetary defense. The object that hit Neptune was several kilometers across. If an object of that size were to hit Earth, it would be a civilization-ending event. In a very real sense, by studying Neptune's wound, we are learning how to protect ourselves. From a scientific perspective, this is an unprecedented opportunity. It's like a geologist getting to watch a volcano erupt in real time, or a biologist witnessing the birth of a new species. We get to watch for the first time how an ice giant's atmosphere weather chemistry respond to a massive external shock. Every observation Webb makes of Neptune from now on will be priceless. Scientists will be poring over this data for decades, building new computer models and writing new textbooks. It will inspire a new generation of planetary scientists and astronomers, fueling their curiosity and driving them to ask new questions. Ultimately, this discovery matters because it sparks wonder. It reminds us that we live in a universe that is more dynamic, more surprising, more interconnected than we can possibly imagine. It connects us to the cosmos. That faint blue dot 2.8 billion miles away is not just a static picture in a textbook. It's a living, breathing world that has just undergone a dramatic and violent transformation. And we were here to see it.